Elite women's cricket demands peak physical performance today. But how do athletes reach their absolute limits? The answer increasingly lies in advanced sports science, specifically biomechanics. This field analyzes human movement, optimizing technique for power and safety. Today, we dive into the science behind women's fast bowling. Understanding these principles helps bowlers generate incredible pace. It also significantly reduces the risk of debilitating career-ending injuries. From arm drive to foot landing, every micro movement matters here. Let's explore how science transforms raw talent into athletic precision. Fast bowling involves a complex chain of biomechanical events. The run-up builds momentum, crucial for generating speed. Then, the jump and gather phase stores elastic energy efficiently. Next, the back foot contact provides a stable base for rotation. The front foot landing is critical for energy transfer. Bowlers must brace their front leg to propel their body forward. This bracing action converts horizontal momentum into vertical force. Arm pull-through and wrist snap add crucial speed to the ball. A smooth, coordinated action minimizes stress on joints. Coaches use high-speed cameras to dissect every single frame. They analyze joint angles, ground reaction forces, and muscle activation. These measurements reveal hidden inefficiencies or injury risks. Women's fast bowling presents unique biomechanical challenges. Differences in skeletal structure and muscle mass are present.
For instance, the wider Q angle in female hips affects knee alignment.
This can potentially increase vulnerability to specific injuries. Researchers study how these factors impact bowling actions. They develop tailored training programs for female athletes. Strength and conditioning focus on core stability and joint resilience. Targeted exercises help mitigate these inherent biomechanical differences. Science is directly impacting individual player performance significantly. Take Ellyse, a leading all-rounder for Australia. Her bowling action has been meticulously analyzed for efficiency. Biomechanists helped refine her technique, maximizing pace and control. Similarly, Shabnim Ismail from South Africa boasts incredible speed. Her explosive release is a result of precise kinetic chain optimization. Data from motion capture labs guides their personalized training regimens. These insights are crucial for maintaining peak performance longer. The future of women's cricket pace depends on continued research. Advanced sensor technology offers real-time feedback to players. Wearable devices track load and fatigue, preventing overtraining. Personalized biomechanical profiles are becoming standard practice now. This scientific approach ensures longer, healthier careers for bowlers. It also pushes the boundaries of what's physically possible on the field. Understanding biomechanics makes our favorite sport even more thrilling. It reveals the unseen precision behind every powerful delivery. The fusion of athleticism and science defines modern women's cricket. This scientific edge keeps top players at the pinnacle of their game. If you enjoyed this, hit subscribe for more deep dives.